Thanks to the organizers for inviting me to come here and chat with you. They asked me to come here and talk about the researcher perspective. And, you know, I'm not really a random researcher, okay? Randomly selected researcher. I'm trained as a computer scientist, and I've worked in biomedical informatics for many, many years. So I thought it would be really interesting to talk a little bit about the antagonism or contradiction or tension between the incentives and the interests of data scientists and bench scientists here. Because it's really important to navigate this if we're going to actually make any progress. And everything I have to say is going to be really connected to the biomedical world, which I know. I can't say very much about the humanities, which I feel that I respect very much, but I just don't work in it. So how can you bring together the perspectives of the computational folks and the actual wet lab guys, right, and clinical researchers? So just to give a little background, so in our world, so NIH very, very concerned about scientific reproducibility and robustness of results. And there are a number of sort of drivers for this. There were some famous papers in the biostatistics world going back to 2005. Ioannidis' paper, most scientific research findings are false, according to Ioannidis. It may be an exaggeration, but I mean, he's got a point that there are a lot of probable false positives in the literature. Begley and Ellis, who were researchers at Amgen, a big biotech company, showed that roughly 90% of the research results from biomedical academic labs that were transferred into their pharma target discovery programs to work on, roughly 90% of them, they could not even reproduce the experiments. This is bad, right? And then there's a question about robustness of results sort of through the pharmaceutical development pipeline. So after you take only 10% of the academic research results that have transferred successfully and take them through the whole process of drug screening and all this and through clinical trials, an additional 95% drop out. That's a lot of failed research, really, in terms of treating health problems. So, of course, NIH is very concerned, and they've undertaken a number of initiatives around this. And this comes at the same time that we have a number of important science policy studies recommending that all primary research data be archived and directly cited in the articles, just as publications are cited. So to be very clear, what this means is that if I publish some new research, I put my data in an archive, and then I say, my data show that X, here's my interpretation. There's a citation with a resolvable identifier like a DOI that goes right to the archive data, and that it appears in the reference list just as if it were a publication. NIH, one of the things that NIH has done is it started something called the Big Data to Knowledge program. They actually now have a directorate of data science headed up by Phil Bourne, who came from UCSD. And the first aim listed on their website for that program is to facilitate reuse or broad use of all the digital assets in biomedicine by making them discoverable, accessible, and citable. Okay? So that's sort of driving a lot of interest and concern about this whole data deposition and archiving idea from the standpoint of actually incorporating them into the scientific communications life cycle in a robust way. And there are a bunch of people that have similar research interests to me are very interested in the ideas of using these things as big data, right, and exploiting them. And there's now going to be an open science prize that the NIH, Wellcome Trust, and HHMI, Howard Hughes, are sponsoring, that is going to probably have somewhat of a focus in this area. And people are very interested in applying. There are incredible advances going on right now in what are so-called deep learning methods. And in fact, I heard a talk a couple of days ago in Peter Sorger's lab at the medical school, at Harvard Medical School, and by a deep learning researcher who said, by the way, academia has hardly any more deep learning researchers left because they're all being scarfed up by Facebook, Google, all these companies, but they are still publishing. Amazing things happening. That is how you have things like self-driving cars, right? But can you apply these to scientific research data from the biomedical field and use this to help cure diseases, right? There are folks like Zach Kohani at my institution, who actually you probably know as the director of the Countway Library, but also a computational biologist, who are really interested in mining electronic health records in combination with open genomics data. So that you use the EHR data as and this is another machine learning type approach. You use the EHR data as a training target, you use the genomics data as a feature set, and you try to train your algorithms to recognize whether certain patterns in the genome are predictive of having certain disorders. So all of that's great, and all the data scientists love this idea, and folks like Professor Kohani loves this idea. We have a little project going in this field, in this area too, for Alzheimer's. It's a little unique, and we're hoping it's successful. There's a big gotcha. So as my friend and mentor Carol Goebel said, biologists would rather share their toothbrush than share their data. And their definition of data mining in biology is my data is mine and your data is mine. Okay? You'll note, so this image here came from a talk by Dave DeRoer from Oxford, the aphorisms from Carol Goebel, and by the way, they're both computer scientists. Okay, so already you're seeing there's a little tension here. We have a jaundiced view of the ownership pretensions of wet lab biologists to their own data. I put own in quotes. So this opens up the question of motivations and incentives. So who's motivated towards open data? Science policymakers. They want to make the science right and make it productive. NIH, cure diseases. Data scientists, great, I can do more research on your data. Bench scientists, nope. Their excuses, we'll call them, because I'm speaking from my perspective, are if I publish my data, I'll get scooped. If I did all the work, why would anyone else have the benefits? It is my precious. My postdoc has it somewhere. Oh wait, he left for Italy. Now, but there's another side to this, and you can sort of, I don't want to be too provincial about this as a data scientist. Data scientists can be quite extreme on this topic, and I think it's very unproductive the way some of this is coming out. All data must be published in RDF. If you don't know what that is, it's a resource description framework. It's a semantic web term. Column headers must be normalized to a formal ontology specified in W3C web ontology language. So I can use my cool semantic web tools on it. It's obvious that's an important goal, isn't it? And when we talk about, biomedical ontologies, very important in biology. The National Center for Biomedical Ontologies at Stanford has 468 of them cataloged, with over 6 million classes. These are web ontologies formalized as description logic, so a class means a term. It's a lot of terms. Yeah. Why can't the bench biologist master all these terms? Seems pretty reasonable to me. The ontologies are precious. Our ring of power. So there's a tension. And it's a little tricky because, remember a few slides ago I lined up the science funders or I should have said the science funder, yeah, NIH, the science policy people and the data scientists. We're all in the same boat, right? We're all big advocates of open science, open data. So maybe we're going to gang up on those bench scientists. But if we gang up on them and try to make them do something that's way over the top and it's sort of too much for them to bite off, they'll just game the system. They'll find a way to get away with not doing it right and doing it, in a way that they can live with. The point is, how can everybody live happily when you have counter incentives? When you have publish or perish, right? And we want to publish, but we want to publish on your data, Mr. Bench Biologist. No, sorry, it's my data. And I'll choose the data scientist with whom I collaborate, and he'll be on the paper, and I'll control the publication. And by the way, I will be the senior author. Data scientist will be the middle author. I forgot to mention the publishers. So they're also actually and peculiarly incentivized towards open data because actually you need their article, we'll say it's theirs, because they control it, to understand the data. The pretensions of we semantic web workers notwithstanding. Some of them, like Elsevier, are working towards very large big data infrastructures which they hope to monetize. Surprise. So maybe this is a fool's errand, but I think that it's important to achieve harmonization. I think that we should require data archiving to achieve publication. I think that we have the possibility to get there if we smooth the path for authors and publishers and make it a gentle ramp rather than walking up to a 400-foot cliff. And we should listen carefully to my friends and colleagues, the semantic web and data science people, but do not let them go crazy. That is a recipe for disaster as well. We all want to be around the table and incentivized, even if we all have different perspectives and come from somewhat different places. We want to be incentivized to come to the table and participate. So I said that there were science policy initiatives and studies that recommended data citation. There was a harmonization effort undertaken for those back in 2014 called the Joint Declaration of Data Citation Principles. I was involved in that, but I did not organize it. But it was organized by colleagues of mine in an organization called Force 11, Future of Research, Communication, and E-Scholarship. And very important. And I think there were people here that were involved in this, right? Yes. And it brought together people from the National Academies, Library of Congress, CoData, and so forth, to boil all these studies, which otherwise I believe would have become shelfware, as is the fate of all big studies, to 8 principles. Then something that I did actually lead subsequent to that was another Force 11 working group to develop implementation guidelines, these are principles, well, great. And over 90 organizations, almost 100 organizations, including a lot of publishers, signed up as endorsing these principles, which was pretty cost-free for them because they were only principles. So we developed some tools and guidelines that we thought would be useful in actually showing people how to implement them. And the big ones were, we revised the JATS, the Journal Article Tag Suite, which is an XML schema that lots of publishers use and the PubMed Central and other people use to archive articles. We modified it to support citing data, and we got the National Information Standards Organization to sign off on that. So that's out there now. It's a tool. And we published an article with some co-authors in this room recommending certain things that need to be done on the repository side and so forth. So that's helpful. We're now taking another step. We have funding from NIH, Data Science Directorate, to run a one-year data citation pilot for early adopters. So people, journals, publishers who are really ready organizationally to implement data citation, to get them to actually sign up to get it off the ground within the next year. So our idea is point of publication is point of leverage. Get the adopters on the same page and provide long-term incentives. Long-term incentives for the data scientists, delayed gratification, eat dessert last. So the objectives, coordinate and guide. We want to get one or more benchmark implementations of data citation in real journals in their production process across some key use cases. And the focus is not really citing data that's already been deposited, which is important, but we thought the most important thing is when I'm publishing this data that's backing my findings in a new research study. Because that's the point where you get the stuff into the archives. And hopefully the biggest thing will be actual implementations in the field, and then we will report on the lessons learned to the community. And we'll change any of the recommendations that are out there that turn out to not be workable in practice. These are some of the participants. I think it's interesting. And thank you very much. Columbia University is a participant. And if you want to find out more about it, you can click that link. And I guess you're going to put this up someplace so people can access it. And I always like to provide references for my slides. Here are your references. And that's really all. I thank you very, very much.